I'm just going to give a small recap on yesterday's session. Yesterday we have seen what is a name node and what is a data node and what is a secondary name node. And we have introduced what is a job tracker and task tracker, but job tracker and task tracker we'll see in detail later sessions. The job tracker and task tracker it requires, it will come into picture when we're processing the data. As of now, we are learning how to store the data into cluster, right? At this point, no need to worry about job tracker and task tracker. We'll see more detail about job tracker and task tracker in the later sessions. So, as we explained yesterday, what is a name node? As I said, name node is a master node. It manages a namespace. It will not store any actual data. To manage the cluster, it will maintain, or to manage the namespace, it will maintain metadata of the data nodes. Ideally it is where the data is stored. And also, it is a centerpiece of, it's a centerpiece of, in the cluster it is a centerpiece where we can say, if you want to store some data or if you want to process some data, we have to contact a name node. Okay, without name node, we cannot talk to our cluster. Okay, if you want to store the data, you have to talk to the name node, and name node will give you the addresses where you have to store the data. Clear about name node? Anyone has any doubts about name node?
Ravi.
Yeah.
So I have a question actually. This is from the day one.
Okay.
So these are name. You said like the name node carries the metadata in metadata, or is the details of the metadata?
Okay. Metadata in the sense here, it's a block to file to block and block to data node mapping. Let's say I want to store a file called employee in the cluster, which is the 1 GB or 10 GB or 1 TB. Okay. And the data will be broken into pieces, blocks, as per the configuration, right? Now, what are the blocks is belongs to this file, and these blocks where and are stored, and what are the machines it is stored. That is one information will be there. Along with this, it will maintain the information about the data nodes as well. What is the current task is running on the data nodes and how much space is available. There is
data. This is the metadata, which is the information about the actual data, right?
Exactly. It is a
metadata is nothing but information about the actual data on the data node and the statuses.
Exactly, Rama. Yes, correct.
So that's where actually I confused. Yeah, thanks.
Okay. So anyone has any doubt before going to next? What is a data node? Okay. Now we have seen what is name node. Then I would like to know from you what it does when we restart the name node. What is the functionality? What is the process will run when I start the name node? Can anyone guys can go ahead and try to explain from the yesterday's session? Previous quickly. So then if you want me to explain, I'll go ahead and explain. Not a problem with that. I suggest instead of typing, you can go ahead and switch on your mic and go ahead and talk. Fine, not a problem. I'll go with. So instead of when name node restarts, what will happen? What's the process it's running? So let's assume we don't have a secondary name node. We don't have the secondary name node. We didn't configure it. When name, so as we know that when we interact with the cluster, whatever the data you want to store in the cluster or whatever the operations you want to do with the cluster, each operation, I can say each operation like you are storing the data or you are creating directory in the cluster or you are modifying the directory or you are deleting some data, these kind of operations. Okay, not the data processing, these kind of operations. Whatever the operation you do with your cluster, each operation will treat it as a transaction. Okay, transaction to the cluster from client. these trans- these transactions these transactions will be uh may I know who is this? Jay, yeah, Jay, I am able to hear you. Okay. So each interaction with your cluster will treat as one transaction. These transaction details will be will be recorded into edit log. It will be recorded into edit log as well as the RAM in the memory, the name node's main memory. Why it will store in the main memory? Because it is an operation. Let's take an example. You have opened some Word document or you have opened some text file. While you're typing, while you are writing into the text file, where it will store in the primary memory, which is a RAM. Temporarily store there. Once you save it, still you accessing it, it will be there in the RAM. Once you save it, it will go and save into your local persistent, like your local hard disk persistently. The same way here, each transaction will be recorded into edit log, which is there in the local hard disk, name nodes local hard disk, and each transaction will be maintained in the RAM as well, right? Now, we didn't restore the cluster for 60 days. Let's assume that multiple projects are running on the cluster and there are so many millions and billions of transactions are going with your cluster. One second, guys. Yes, Jaya, I am able to hear you. I think everyone is also able to hear you.
Ravindra?
Guys, I think some people are facing they're not able to hear me or they're not able to see my screen. Does anyone facing the same issue? If anyone facing this kind of issue, better re-log in. Most of the cases, re-logging will resolve the issue.
Yeah, are you able to hear now?
Yes, Ravindra, I'm able to hear, but some of those guys are not able to hear.
No. I'm asking Jaya. It seems like he is facing problem.
Okay, I'm
So
continuing.
if anyone facing same problem, like I suggest to install the client, that is GoToMeeting client rather than attending from web-based. So if you if you visit the GoToMeeting website, there we can download the app. Using the app, we can directly attend the meetings. So with that way, like we can avoid these kind of problems. Okay, if anyone facing same problem, let us know. Thank you.
Yeah, thank you, Ravindra. Okay, as I said, if you are doing more transactions, millions and billions of transactions with a cluster, like storing the data, modifying the data, deleting the data, creating new directory, these kind of operations. When you do more transactions, these entries will grow. These entries will go into our edit log. And what we have assumed that we don't have the secondary name node or we don't have the checkpoint node. The secondary name node itself will call as a checkpoint node. We'll talk about that later. When the name node restarts, when the name node restarts, what it will do?
యాక్చువల్గా జనరల్ క్వైట్గా ఉంటే డౌట్ వచ్చింది నాకు.
Okay. So when your name node restarts, what it will do? It will start merge your fsimage with edit log. Why it has to merge? Because edit log is a kind of a log file. Fsimage is some file system image. Your name node will make use of fsimage only to get into functional or to understand what are the data nodes, to understand the metadata. Okay, it will always load a fsimage only, not the method edit log, because edit log is a kind of log file. Okay, and also your fsimage will have some high end, or I can say good information like permissions and who is the data belongs to whom. This kind of information will be there. We're going to see them in a couple of slides. So as I said, we have interacted multiple times, like more than a million and billion of transactions. So now my FSM edit log has become a huge, my FSM has become a large. Now to merge my edit log with FS image, it will take some time. My FS to merge this FS image with edit log, or edit log with FS image, sorry, edit log with FS image, it will take a huge time. That while it is merging, our name node will be in a safe mode. While it is merging, name node will be in safe mode. What is the safe mode? Safe mode means the system is alive, I mean the cluster is alive, but you cannot access anything. You cannot store the data, you cannot process the data. To give an example, in Windows we have a safe mode. What is that safe mode? You cannot install any software there. You can just access few of the applications. You cannot install any application. The same way here, you can able to see the cluster is alive. It is starting up kind of information, but you cannot process the data, or you cannot store the data in that. So the time delay to make your cluster up and running, there will be some time delay because of this edit log and fsimage. To avoid this drawback, or to avoid this time delay, we have introduced a secondary name node. This secondary name node we will see a detail on the slide. Okay, how we are avoiding using secondary name node. Okay, understand guys what will happen when the name node restarts, and what is the name node? I think everyone is understand. Please ping me quickly. Please respond to me. I can understand. Yeah, good. Now, what is a data node? Data node is a slave node. Those are our actual workhorses. I can say those are the actual workhorses. And if you take a real-time scenario, if you want me to compare with a real-time scenario, if you take a team, you are working for an IT or working for some any other team, in the team will be having one manager, team manager, and will be having the team members. Okay, the team members will be doing the actual work, and your team manager will be maintaining a status of the team members. And if you take let me take a very small example. If you go with constructing a building or constructing an apartment or construction company, and they will be supplying some human resources, right? There in the whoever supplying human resource, he will be a manager, and they will be having a set of guys who will doing some separate kind of work, who will do constructing, and some guys will do supplying a material, some guys will do the plastering and all those things, right? The manager, there the manager will be managing these people. He will not do any work. He will not go and get the bricks, and he will not go and bring the sand and all, right? He will just manage the team. He will make sure that work will get it done. At the same time, he will be maintaining one register, what guy is doing what, whether he came today or not, whether he's attended today to work or not, right? The same way your name node will be maintaining a registry in the form of edits and fs image. But who is the actual workers? The actual workers are the human guys, who is I can say laborers, who is really working on it. I don't want to use that word, but still, to make understand, I'm using the labor, the person who is really carrying the bricks and really carrying the cement and all. The same way, the data node is a workhorse who really do the work, who really do store the data into them, and who really process the data into them. Like they are workhorses, and they will keep informing to the name node saying that yes, I am alive, I have this data block is stored in my machine, and this is the process currently running. So this kind of information will be keep sending to the name node. Clear about the name data node, guys? It's a slave node. As I said, it's a slave node. Okay. Job track and task track will come into picture when we go with the process, data processing. Like doing some aggregations or some data processing. Ideally, it's a data processing. Whatever the data stored in cluster, when we process, it will come that point. Okay, I'm skipping the job tracker and task tracker because it's irrelevant at this point. So just assume that job tracker and task trackers are the daemon which are running on the background, and job tracker is a master and task tracker is a slave. And job tracker will running on the name node. Just assume that job tracker is running on the name node and task tracker will run on the data node. Okay, and also job tracker can be a separate machine. I will see the what kind of scenarios job tracker has 3 separate machine. We'll see that. Okay, job tracker, the process also, the storing, it is taking the master slave architecture. The same way the process also will follow the master slave architecture. Master will be a job tracker and slave will be a task tracker. We will see in detail when it comes to the map to this point. Clear guys at this one? I'm just moving to other slides. Okay, now secondary name node. We have seen some limitation name node, right? What is the limitation? Name node is taking more time while restart. Okay, and also name node is waiting for data nodes to give the reports. Name node also waiting for waiting for the data nodes to give a report. 80% of the data nodes gives the report. Your name node will start running. It will start function and start running. Okay, and what the limitation was, the time taking. We have seen that it will take so much of time while restarting. So to that duration, the cluster is not available and any application cannot access that cluster. Now to reduce this time, we come up with a secondary name node. The same is called as a checkpoint node. Okay, if anyone asks what is checkpoint node, you can explain the same secondary name node only. Okay, what it is doing actually. Secondary name node is a separate machine. It can be in the same rack or it can be the different rack. Most of the times we will configure in the different rack. So for the avoid the failures or to avoid the fault tolerance, to to avoid the crash in the cluster. So secondary name nodes most of the times we will configure in the separate rack, and it has to be a separate machine ideally. So what is the job is running by secondary name node? The job is running by secondary node is the roles and responsibilities of secondary node is periodically you talk to the name node, get the results, merge them, and give back to the name node. Okay, what is the how it will run? We will configure periodically, and each hour it has to talk to the name node, get the images fs image and edit log from name node, take to your local, merge them, keep on copying your local, and give the latest updated fs image to name node. In between, while merging, in between, if any operation is happened with the name node, any transaction happened with the name node, I mean with the cluster, your name node will create a edit.new file. It's like a new edit file, and your fs image will be updated one. The edit log is the recently created one, and when again the checkpoint meets the checkpoint like 8 o'clock or 9 o'clock, 10 o'clock, 11 o'clock, when it meets that checkpoint, again it will take into the secondary name node, it will merge, it will give back. Okay, how it is reducing the time? Because name node always after the checkpoint, name node has updated fs image, and it might have the less transaction in edits. When it restarts, it will take less time to merge with the fs image. We almost reduce the restarting, or I can say restart time, right? And let me take 2 scenarios here. I want to take 2 scenarios. I just want to explain a limitation of secondary name node as well. Okay, let's assume I'm started doing the transactions, and my name node also has the latest fs image. I have configured jobs every hour. I have configured the job every hour. Let's assume the job has been configured 8 o'clock, 9 o'clock, 10 o'clock, and every hour, right? It is every hour, 11 o'clock. My job is success at 8 o'clock. Sorry guys, sorry for this. My job is success at 9 o'clock. 9 to 10 in between, at 9 o'clock means it has the updated fs image in name node, and there will be new edits. It will start a new edits, right? And in between I have done some transaction. Let's assume 10 transactions I have done. At 9:30 something happened with my machine and it restarted. Okay, what will happen now? Only it restarted. It means that it just restarted. Machine is alive, machine is good. I mean, it is not nothing gone with machine. It just restarted due to some maintenance or something we have restarted manually. Our machine itself is restarted. When it restarted, what will happen? Only these 10 transaction has to be merged with the fs image, not more than that, right? So fs image is already updated one. You just need to put the 10 transaction to fs image because before it's already merged, right? That we have reduced the duration. We have reduced the duration. We have solved the problem. I mean, not completely we solved. At least we shown some performance. 1 second, guys. Just my machine is busy. Okay. At least we reduced the time taking while restarting without name node and with name node. Right? We just reduced. Let me take a second scenario. I have configured 8 o'clock, 9 o'clock, 10 o'clock, and 11 o'clock, and so on. Let's assume till 9 o'clock it is merged successfully, and I was started doing some transactions. Next merge will be 10 o'clock. My system is failed at 9:30. My system is failed at 9:30. Will I be having any data loss? Will I lose any data? 9 to 9:30, I have done a 10 transaction. Just assume that I have done 10 transactions, and it has a latest FS image, and it has those 10 transaction edits. So my machine is failed, completely failed. So I'm not able to recover it. Will I have any data loss here? Will I have any data loss? Guys, could you please respond? Is there any data? I am going to lose anything? No, I'll be losing some data. Because my name node is crashed, completely failed. I'm not able to recover the data. But no, I'll explain. I'll come to that point, Chandu. Okay. So these 10 transactions I'll be losing because the latest FS image already on copy is available in a secondary name node. Where can I get it? And I can make it. But these 10 transactions are not there, not available. These 10 transactions will be there in only the name node where I'm not able to recover that machine, where I'm not able to recover the data. So I'll be having a data loss of these 10 transactions. This is also one of the drawback with the secondary name node. Then how we will solve this problem?
Ravi, here my question.
Go ahead.
So when you said it's a cost, but we still will be having the data in memory, right? So to recover it.
Which memory, Rama?
So it's a like when you said the crossroad means the completely damaged or it's a dead for some time.
I have taken a scenario. I have taken a scenario where it is completely crashed. I'm not able to recover the data by using some recovery tools.
Okay. That
But
means it's like example of fire damage something.
yes, fire damage or something. That case I cannot get any data. But other cases, just failure or something, I can, machine is good, just failure, something happens, some failure, that case I can go ahead and get them, because that will be there in hard disk, that will store in hard disk.
That's right. Yeah. Okay.
So where I have taken a scenario, it's completely damaged, which is not, I'm not able to get the recover the data using recovery tools, or even
Okay.
recovery tools, right? So in this scenario, it is one of the drawback using a checkpoint node or secondary name node. Clear this point?
Yeah.
Okay. Now, how to solve this problem? To solve this problem, Hadoop 2 onwards, we come up with a new architecture. That means there is no big change in architecture. They have just replaced a name node with the other node. We'll see what is that node. Okay, we'll just see what is that node. Okay, before going into the details, I just want to give an introduction to what is the edit log, where you can see edits and fsimage, where you can see fsimage and edit log. In your once the configuration is done, I'll show you that, guys. In your machine, we'll configure the name node, right? In the name node, you'll be having one folder called name. Under that, you'll be having current, version, and edits. This is the transaction ID, started 1 and it's ended at 7. These are the transaction IDs, and these are the edit files will be created, and these are the fs images. Okay, these are the fs images, and this is the latest edit file. And while it is in process, it means edits underscore new. In progress means edit underscore new. During the checkpoint, whatever the edits will write, right, that edits will say edits underscore in progress. Okay, then it will be merged. So whatever is merged, it will put it back. And again, the latest checkpoint image, when it merged with again the in progress edit log. I mean, it's just an idea for you guys. You should also go ahead and change the configurations here. So normally, now by default configuration is 1 hour. You can go ahead and change for half an hour or 45 minutes or more than that. Or the default configuration for the transactions, we have a default configuration 1 million. You can go ahead and say 1,000, 10,000, or 1 million, 1 billion. So which is it's a configurable. Okay. Now, edit log is a binary format. We cannot go ahead and read them. And there is a tool in Hadoop 2. Okay, there is a tool in Hadoop 2 where we can go ahead and read them. Using those tools, at least we can get the some information. Okay, I have used that tool. I just got this image. I mean this information. So to show you what it looks, edit log, how it look. I mean what the information it will contain, and I have done that. But we really can't. It's not a human readable file. I can say it is not a human readable file. To make it a human readable file, Hadoop come up with the different kind of tools. We'll see them. What is the tools? The tools I'll show you in while while we're doing the commands. Okay. If you see, this is start with the edits, and also these edit files, right? You can write into XML files, or you can see it as a text file. But I have taken into XML file to understand more. It will give more information. It is start with edits, and what is a version of edits? It's a 51, and some opcode and transaction ID, and it has some op directory, which is the directory. What is operation? So opcode is nothing but operation code, and here he created a directory, and some what is the length, inode, path where he has created, and timestamp when he has created, and who is the user, and which user which group he belongs to, and what is the mode. These are the permissions. Okay. And when it comes again, one more operation he did the add operation. He did some copying some file, text file, and this is some information. It's just an idea, guys. It's not exactly the same records, same information, same numbers will vary, but edit logs looks like this. Just for our understanding, nothing else. So we're not going to do anything with it in a real time. We're not going to do anything with the edits and fsimage. To understand this, I brought this information to you. You guys can spend some time on this. I can move to next slide. I hope I can go ahead and go ahead with the next slide. FS image. FS image has some more information, detailed information. Actually, people can ask me why they are merging with FS image. Edit log is the same content they are merging, right? Why we have to merge? because your name node always refers the file system image, not the logs. But when you go here, the same kind of information will be there, but with some extra details. It will be having some more, more details, like your namespace. You'll be having a transaction ID, last inode ID, inode, which data node it is, and you will be having some more. Let me see, replication factor. What is the modification time? What is the access time? What is the number of blocks? Okay, what is the disk space quota for it? And who is the user? These are the same. What is his permissions, read, write, right? So these kind of information will be there. I'm moving to next slide, guys. The same information into some other format. That is XML format we have seen. The same information I have written into the file. So when I write into the file, it will comes like this: image version, namespace ID, and last allocated block, some information. Okay, it's just an idea, guys, how it will store in the edit logs and fsimage. We cannot really look at them, but in Hadoop 2, it come up with some tools. It's a commands only. OVI tool, OE optimize tool, OE tool. These kind of tools are there. We'll see. OIV is a tool for view the view FS image. OEV to view the edit logs. We'll see them. Not to worry about it now. It's not, no. If you didn't understand, also fine. It's not good. It's not may make you any confusion state. Okay. Now we have seen a drawback in the secondary name node. Right? What is the drawback? If name node crashes completely, we are losing some data. Maybe that data may be valuable data. So if we lose that data, we may lose some valuable information, right? To avoid that, Hadoop 2, we come up with a new concept or new node is a backup node. It is a replacement of our secondary name node. Give me 1 second, guys. I'll just take a sip of water. Now, how it works? As we know that our name node, secondary name node, will keep talk to the primary node, name node, right? Keep in the sense every half an hour or every hour, what depends on the configuration, right? Let's assume I'm just taking small background. It's a name node. They keep talking to these guys. Now how the it is secondary name node. And I have the client and all. I didn't. Okay, just take and the client. Okay, what name node when it will do? It will periodically it will start talk to the name node periodically, hourly basis, or when the transaction meets the limit, when it reaches the checkpoint, I can say when it meets the checkpoint. So that time it will start downloading the data from the name node and it will merge it and it will upload, right? 1 second, guys. One second, guys. I'm just some guys trying to join, but he's not able to find the meeting ID. I'm just giving the meeting ID to him. Okay. So periodically or hourly basis, when it will start checkpointing, one is hourly basis, based on hourly basis. Second is the transactions, number of transactions, right? So we have seen the drawback. Now HDFs Hadoop 2 come up with a new architecture saying that they have replaced this name node, secondary name node with a backup node. Let's assume the name node has the secondary name has been replaced with, just assume it's a backup node. What this backup node will do? It will keep interact with the your data node, your name node. It will keep interact with the your your backup node will keep always sync with your name node. Whatever the transactions are doing with your cluster, that will be updated into name node's RAM. The same information will be updated into your backup node's main memory. The same information. Again, your backup node also maintain fsimage and edit log in local hard disk. Okay. Here it is avoiding downloading and uploading phase. It's always sync. Even though your data nodes are not reporting to the backup node, these data nodes are not reporting to the backup node, it is updating to your name node, right? Whatever the update will come into your name node, it will take your backup node will take them into their memory and they'll write into edit logs and fsimage. It will also maintains edits and fsimage. Okay, so your backup node is always sync with, your name node. So there is no chance to lose the data. Whatever the data is available in the name node, the same kind of data will be available in the backup node. Even though name node crash completely, your backup node will have the same state, latest state. You are not going to lose anything. In the earlier case, we are periodically updating on every hourly basis or every number of depends on the number of transactions we are merging them. Where we used to download them, where merge we used to upload to name node. But in this case, your name node will always take keep sync. Okay, it will be syncing with your backup node. Okay, and it is avoiding that phase where we are losing some data. Clear about this? Okay. And the main constraint is here because it is keep syncing with your name node. Your backup node should have a same kind of configuration, but here if the RAM is 128 GB, here also should be 128 GB, and if the processor is the same kind of processor also should be available here. I think this diagram will illustrate you to it's a keep syncing you, or it's keep in sync with your primary name node, and to avoid that case. Clear, guys? I'm moving to next slide. Okay, here before here, I would like to spend some more time for what is the drawback of backup node also. I just want to explain what is the drawback of backup node also. There's a small slight drawback here. I just want to explain that. The drawback is your backup node. Let me take an example. Does anyone has any doubt about the backup node? Configurations and all, how we will do, what are the configurations required, it is those details we'll see. I'll be giving you a proper notes for it. I'll be uploading that notes configurations at this point. We may not need that. I'll be showing what are the configurations involved in, what is the checkpoint node, how we'll import, how we'll export those configurations. I'll be making your notes, I'll be uploading it. When you refer the notes, it will be very much clear. Name node, data node, this is backup node. Okay, Even here, using backup node, we are avoiding losing the data. We're just avoiding the losing the data. But still, if your name node is failed, and failed in the sense completely crashed. Let's assume your name node is completely crashed, and your backup node will take the copy because it will maintain the latest copy from the fsimage. It will be their latest copy in our backup node. We can take into the new machine. We'll copy to the new machine. We'll make it up. So what is the scenario? The scenario is your cluster is failed. So what we have to do? Get the backup, get the fsimage from bkp node, and take a new machine, copy into new node, copy to new node, and make it up. Right? It will take some time to copy the latest state from the backup node, and you're creating a new node and make it up. It may take an half an hour or 45 minutes. This half an hour and 45 minutes, your machine will be, your cluster will be down, and any of the application cannot access that. Any of the application cannot access while we're making a new backup node. Guys, am I clear? Are you guys following me? If you're not following me, I'll just repeat one more time.
Ravi, can you repeat this one more time?
Okay, sure. See, we have this setup. Now I don't have the secondary name node. I have made it as a backup node. My backup node always sync with my name node. So I'll be having my backup node will be having the latest image and latest fsimage and edit log in the backup node. Let's assume there is a scenario where my machine is crashed. My name node is crashed. Crashed in the sense completely gone down. I'm not able to recover it. Completely failed. Failed scenario. Name node is failed. I'm not able to recover it. It's completely failed. So what we will do? Either we will make a backup node as a primary name node, and we'll get this other machine for the backup node. Some configuration changes and all. Else, if already hardware is available, what we will do? We will take a new machine and we'll get the copy from the backup node, and we will load into the new machine, new hardware, and we will make that new hardware as a name node. Clear this point, Ramya? Ramya, could you please?
Ravi,
Yeah.
Ravi, here my question is actual name node and backup node. So are they sync every time?
Yes, are they sync every time? Every time. It's always sync.
So for okay, so it's like almost like a cluster in servers.
Yes, correct.
Okay.
Okay. Now, go ahead, Jai.
Yeah. See, if you were saying the new new hardware is going to act as a name node, am I correct?
Correct.
So in that case, what are the configuration of name node configuration? Is it how it understand is it a same configuration details the new hardware? Is it anything we need to provide?
We need to install. Yes, we need to install it, Jai. It's a brand new hardware. It doesn't have any software. In that, we have to install.
It doesn't know anything, so we need to configure anything
yes, we have to
simply
no. I cannot blindly go ahead and put into the cluster. What I have to do, I have to install the software. After installing the software, in that there will be having a master file. There I have to specify the IP addresses. There will be some configurations will be there. After configuring only, I can go ahead and keep it in the cluster.
Okay. So when you patch, you can join, it won't automatically recognize you. How to
No.
specify some process?
Yes, we have to specify some process.
Okay.
Veera,
yeah,
this is Vignesh.
Tell me, Vignesh.
So you mentioned it's a drawback to that backup name node, right? Actually, okay. I mean, you can't say it's a drawback, right? It's a architecture behavior. I mean, for the
limitation. I might have used the wrong word. Limitation. It's a limitation.
Okay. So when you say limitation, right? So my question is, so when this thing is in cluster, why can't we bring up that secondary name node as a name node primary? And when you install a new cluster, in the meantime, we can take a FS image from the backup name node and make that one as a secondary name node.
We can do that. So, okay, you are telling that in the cluster we have one backup node, one secondary name node also, right? No, that's what
No,
your point.
see, the name node is failing. Is failed. You said like 20 minutes or whatever the time it will take to bring up the name node back to copy. You are copying the FS image from the name node and placing into the backup node and placing into new name node,
Correct.
right?
Correct.
So in this case, like there is a downtime.
Yes, correct. There is a downtime.
So instead of that, we can bring up that secondary name node as a name node.
The secondary name node you're telling that backup node only, right?
Yeah, a backup node, make it as a name node. We can't make that.
Yeah, we can
And
make it. We can make it, but still it will take some more time. It will take the configurations we have to change. Again, that has to be done manually, right?
Fault tolerance, right? It will automatically. There is an heartbeat signal between these two racks, right?
Correct. There will be that understand, Vignesh, but your backup node is not configured that way, right? Backup node has its own
Backup
configuration.
node is not configured that way. Okay.
That way, right? We have to do it manually by changing.
So the configuration is not in the sync.
Not in the sync. Only the memory will be in the sync.
Okay.
Okay. To avoid that also, I mean, there is some more advanced configuration changes, or they come up with some more. It's not architecture change. It's just like a configuration changes. Okay. Even if you want to go ahead and change the configurations, again it will take some time, 10 minutes, 15 minutes, 20 minutes. I don't want that time delay also. What I am expecting highly available. If one guy is not available, immediately the second guy will come and take roles. I don't want to miss some milliseconds or some delay. So that architecture change we are going to see now.
Okay.
Yeah.
Yeah.
Ramya, is your question clear? Is your doubt is clear? Okay, good. Now, to avoid the time delay, to avoid that few minutes compared to the old approach, this approach is reducing sometimes. Again, still, it also has some time delay. To reduce that time delay, also, the Hadoop to come up with a, a feature called a feature called 1 second, guys. Highly available HDFS high availability. HDFS high availability. HDFS high availability. What they'll do, they will have two name nodes here. This is name node 2. These guys also will start reporting to this guy. Like in a team, two managers. In a team, two managers. Like we have a 50 members team or 60 members team. So there is one UI team and there is an ETL team. Okay, backend team. And it's a very difficult to manage by okay, I think it may wrong in bad example. Let's take we have one manager. The manager is going on vacation, so someone has to take roles and he has to respond to the client and he has to take some roles, backup, some kind of backup for the manager. So that I should not be having some delay to understand what what the primary manager was doing, and what he should not take some time to understand what he was doing, and I'll go ahead and take the roles. He should also sync with the primary manager. Like the primary manager anyway will be getting the status from the employees, I mean team members. The backup manager also will keep getting the same kind of status, right? These two guys are on the same page. Your primary manager and your backup manager both on the same page. Okay, when your primary manager went on vacation for 10 days, 20 days, your backup manager can take a roles. I mean, can take a, you can go ahead and continue the assigning the work or get it done. You should not take some time to get understanding what the primary manager was doing and all. That kind of scenario it is. Here we will maintain two name nodes in the cluster. One is active. One guy is active. This guy is active, and this guy is standby or passive. These data nodes will keep informing both. This both the guys, all the team members will be informing to both. They're keeping the CC. Always they'll keep them into CC. What are the information which they're sending to this guy? Always they have to keep CC in this guy. Okay. Whenever he went on vacation, this guy will take a roles because he knows what is going on in the team. There won't be any time delays required for him. He don't want any time take to understand what this guy was doing, because this whatever the active guy, I mean whatever the primary manager knows, the same information is there with the backup, I mean standby manager. So whenever he is not available, he can go ahead and take a decision, and he can go ahead and continue the work without any time delay. This is called HDFS high availability, Hadoop high availability, or else say HDFS high availability. Clear guys about this? And configuration and all, as I said, yes, configuration, there are some configurations. We will see them in detail. This is the theory, just on understanding the cluster, understanding the architecture, how it is going. Clear about this? If you guys give me responses quickly, then I can go ahead and continue with this. Rama, Ramya, Vignesh. Okay, right? Still, I do see a limitation here. What Ravi, you were telling new concept, again you were telling the limitation. It's not like that. The versions are increasing, right? Now the latest version came. The latest version Hadoop 2. They also have some more extra features. They found there is some more limitation in this cluster. They found there is some more limitation in this cluster. That limitation is, let's assume I have a 4,000 node cluster. Okay, let's assume I have 4,000 node cluster. All these guys, your name node or your secondary name node has to maintain a single namespace, kind of root, kind of user, then your name and the data. This namespace is single. Whatever the data is coming into the cluster, in the 4,000 node cluster, 4,000 nodes, it is maintained with a single name node. It is maintained with a single name node, which is overburdened to your name node. It is overburdened to your name node. To avoid that, Hadoop 2 come up with a feature called hdfs federation. A feature called federation. That's called federation. What they have done here? They have done, let me take a small diagram to explain this. They come up with a new feature called Hadoop Federation. What this Hadoop Federation will do? Please bear with me guys, I may bad in the diagrams. Today my system also is working, it's hanging multiple times. Okay, this guy is name node 1 and this guy is name node 2. What they have done, they have split up the namespace two namespaces. One namespace will be handled by the green color guy, and I mean one name node 1. Other namespace will be handled by red color one. Like they have splitted the namespaces root, whatever that comes under root, whoever wants to store the data under the root, while we're putting the location, will give the location path, right? Path location output path. Hadoop fs hyphen put will give the destination source and destination. The destination path, whatever comes under the root, will handle by this guy. Whatever comes under other namespace, like let's assume the share, will handle by other guy, other name node. So now we have reduced some burden in these guys. We have reduced some burden on this. In the previous approach, only one name node was only controlling whole namespace. When it comes to the Hadoop, but it was not a solution for the previous problem. It is not there is it's not a problem because cluster. I have a huge cluster. I want to make it high scalable or highly maintainable. So what they have done, they have split it like this. And again, these name nodes should have a backup node, or this name should also have a backup node. It can be a backup node. It can be highly available. It can be highly available. It can be HA or it can be backup node. Both guys should maintain their own backup nodes. It can be backup nodes or it can be this kind of a highly available cluster. It's like a two cluster ideally. This is like a two clusters, and they should have their own backup nodes for each name node. Is this clear, guys, or it's confusing? Okay, I'll repeat it. Okay, so I have a huge cluster. It is not a solution for the it is not a solution because it is a new approach, or it's a new I can say new design where you have a huge cluster. So reduce the burden on the name node, they come up with a new architecture change. What is that architecture change? When you have a huge cluster, instead of maintaining one name node and that name node has to maintain single namespace, instead of that they come up with a two name nodes. Two name nodes. One guy will handle one namespace, other guy will handle other namespace. What is a namespace? Namespace means when you are storing the data, will be specifying the destination path. Whatever the data comes under root, whatever the data comes under root, that will be taken care by name node 1. And whatever the data comes under share, it will be managed by name node 2. And these guys should have their own backup nodes. Name node 2 should have its own backup node or high availability, and name node 1 should have its own backup node or high availability. Here, these two different guys are maintaining two different namespaces. Ideally, it is like two different clusters, which will act as a single cluster. Chandra, is it clear? So being a user, sending a data, storing the data, we know we're not going to worry about it. But who is configuring, really administration guys, who is going to configure a huge cluster, they have to understand these architectures. By being an end user, being a developer, we are not going to worry about these things. But we should know the concept, how it is working in the, when it is a huge cluster, when it's a small cluster, how it is working. And what are the configurations they have done this. Just a knowledge for us that we're not going to do regular basis. One second. You said two different clusters maintain the same data as well. You said two different clusters will maintain same data as well. No, it's not same data. One name node will maintaining one data which comes under C drive. Let me take in this way. One name node will maintain the data who comes under the C drive. Other name node will maintain the data who comes under D drive. The same cluster only, we have two name nodes. One guy will maintain only whatever the data comes under the C drive. He will be understanding that much only. He will be maintaining the metadata of that C drive only. Whatever the data comes under the D drive, he will be maintaining that D drive metadata only. Chandu, is it clear? Good. So this is about architecture changes and solutions and problems and solutions, and you can go ahead and see job tracker, and I will look at when Maplets comes. So we have seen this, and these pictures already have seen. So we need to do the setup. So I have uploaded the documents into the drive, which is shared by Ravindra and me. So have you guys done any tried do some setup, or trying at least tried to install Ubuntu or something? Okay, guys, is it your setups are ready, or shall we go ahead and do your setups for some time? I think I have shared them into a cluster. 1 second, I have already shared into the drive.